Answer on this is 145. Answer on this one is 4. Answer on this one is 137. Answer on this one is 4. Answer on this one is 31. Pick a number from 1 to 10. The winning number today is 10 and 3. Homework check today is for the after-test assignment from Friday. Don't bring it up all at once. I'll let you know what row has to bring it up. For today, the objective is 9th grade patterns, functions, and algebra number 1, which is the first red card on the wall. We'll be on those at least until Christmas or maybe after. The learning target for today is I can determine if a relation is a function or not. And before we start on the examples, here is what a function looks like. F of x, this is pronounced F of x, equals 2x plus 5. The f of x is the same thing as writing y. Y equals 2x plus 5. This is because you're going to enter in numbers for x and get back a result for y. You're going to create ordered pairs. In other words, it's also a table of values. You're going to insert numbers in for x and come out with answers for y. The x numbers are called the domain. That's what's put in for x. Any numbers you put in for x, that's called the domain. Any numbers you put in for y, or you get back for y, are called the range. What goes in is the domain, what goes out is the range. X, domain, y, range. Let's put these numbers in and see what we get back. If I put a 1 in here, it's 2 times 1 plus 5, which is an answer of what? 7. What if I put a 2 in here? What do I get back? 9. What if I put a 3 in? And if I put a 4 in, I get a 13. So everything that we just came out with is an ordered pair. I put in an x value of 1, I got back a y of 7. X was 2, so y was 9. X was 3, so y was 11. And x was 4, and y was 13. Ordered pairs. For every domain element, there is exactly one range element. This is the pop machine example. If I put $1 into the pop machine,
Excuse the interruption, when the bell rings, I need Zach Jones to the office.
if I put, after all the interruptions from the noise in the hallway and then the intercom, I have to start this over. So this is a pop machine. If I put $1 in and press this button, I should get back a can of Pepsi because the button says Pepsi, unless they load it wrong, but that's not supposed to be what happens. If I go back the next day and put in $1 again into this machine and hit this button, I should still get back a can of Pepsi. I should not get Mountain Dew back. This is a function. Every time you put the same thing in, you should get the same result out. It should not change. That takes us to example 1. We want to determine yes or no. Is this set of ordered pairs a function? The way you determine that is by looking at the x numbers. We have 1, 6, 4, and 5. If they are all different, then the answer is yes. If all of these x numbers are different, the answer is yes. Example number 2, I have a set of ordered pairs and the x numbers are 1, 7, and then there's another 1. Remember the pop machine example. If I put in 1, It's a record-setting day for interruptions. If I put in a 1 and get back a 6, then I should be able to put in a 1 another time and get back a 6, but instead I got back a 3. So that means this is not a function. The answer would be no. You cannot have the same x value twice and have that number be associated with two different numbers. If you had this show up twice, instead of this, if it were this point, which is the same as this one, it would still be a function. Because if you put in 1, you get back 6, and that's what happens here.
So it'd be yes if that happens?
If that happens, the answer is yes. But if it's two different y numbers, but the x numbers are the same, the answer would have to be no. Practice problem number 1, yes or no. The solution for the practice is we have 7, 3, 4, and 8. They're all different. Therefore, the answer is yes. The bonus problem is 3x equals 13 plus 2. That's a 15. Divide by 3 to get an answer of 5. Practice problem number 2. The solution for the practice, you have 1, 6, 3, and 5. They're all different, so the answer is yes. For the bonus, it should be negative 3x equals negative 40 plus 7. That's going to be a 33, or a negative 33, and you'll divide that by negative 3 to get 11. Example number 3. You have the domain on the left and the range on the right. Remember, this is x and this is y. Also remember that each domain element can only be associated with one range element. So if you go down the domain list, you'll see that 2 points to 12, 3 to 9, 7 to 13, 9 to 16, and 11 to 12. Notice that only one arrow is leaving each domain element. That means it's only pointing to one each. Therefore, the answer is yes. This would be a function. Take note of this instance here. You have 2 pointing to 12. You also have 11 pointing to 12. That is possible because only one item is associated with each domain element. Example number 4. In this case, we have 1 pointing to 6. But when we get to 2, we have 2 pointing to negative 3 and 2 pointing to positive 3. You cannot have that. That means this is not a function. The answer would be no. Practice problem number 3. The solution for the practice is that you only have one range element assigned to each domain element. Therefore, the answer would have to be yes. Practice problem number 4. Look at each of these numbers. You only have one arrow leaving each one of them. Even though they all point to the same one, there's still just one number per domain element. Therefore, the answer is yes. The graduation test problem is worth 3 million. Write down A, B, C, or D using capital letters. To find what's equivalent to this, you must multiply 3 by x to get 3x, and 3 times minus 6 is minus 18. 4 times x is 4x. 4 times plus 7 is plus 28. Therefore, D is the answer. Time for some speed problems. This will go to the first 6. I'll give it to the first 6. Nothing special to the first 1, just to the first 6. 3 million to the first 6. Answer should be 16. Number 2. Answer is 126. Number 3. Answer should have been 72.
Jeez.
Number 4. Answer should have been 90. Last one. Answer is 61. Next up is example number 5. What are the range elements for f of x equals x squared minus 3 if the domain elements are 2, 4, and 6? It's very simple. Plug each number in for x. So if I put a 2 in there, what do I get back? 1. If I put 4 in, 13. And if I put 6 in, 33. Yes, and so everybody understands I put a 2 in, squared it, and subtracted 3. That's 4 minus 3. That's where 1 comes from. I put a 4 in. That's 4 squared minus 3. 16 minus 3 is 13. And I put a 6 in. 6 squared minus 3. 36 minus 3 is 33. And this is what you would write down in order with commas in between the numbers. Here's example number 6. What are the range elements for f of x equals x squared minus 2x plus 1 if the domain is negative 1, 0, and 1? What if I put a negative 1 in for x? What should I get back?
You should get 2. I mean, negative 2.
If I put a negative 1 in and square it,
Negative 1.
and then a negative 1 here,
0.
1 plus 2 plus 1.
Oh. I didn't know it had to be in parentheses right there.
Yeah, you have to put it in parentheses. Wherever there's an x, you have to put parentheses. That should give you back a 4.
That helps.
If I put in a 0, this would be 0, this would be 0, so I'm left with what?
1.
1. If I put a 1 in, I get 1 squared is 1 minus 2, which is a negative 1, plus 1 is 0. Practice problem number 5. Okay, if I put 1 in here, 1 plus 1 is 2, squared is 4. If I put a 2 in, 2 plus 1 is 3, squared is 9. If I put a 3 in, 3 plus 1 is 4, squared is 16. Bonus number 5.
I'm not going to put yes this time. I forgot what
This should be negative x equals negative 12 minus 5. That's a negative 17, but you have to divide by the negative 1. That makes this positive. Practice number 6. On the practice problem, if I put in a 2, that's 2 minus 1 is 1. Squared is 1. Times 2 is 2. Plus 2 is 4. If I put in a 5, that's 5 minus 1 is 4. Squared is 16. Times 2 is 32. Plus 5 is 37. And then 7 minus 1 is 6. Squared is 36. Times 2 is 72. Plus 7 is 79. Bonus number 6. Answer on the bonus is 0. The solution for this one, you have 3, negative 4, 6, and negative 3. These are not the same numbers. One's negative, one's positive.
Oh,
Answer should be yes. Homework for tonight.